Hello everyone, welcome back to another video on crack concepts. So today's video is going to be about 5 most important SQL interview questions for beginners. So if you are a beginner, you need to know these 5 questions. So let's begin with the video. So where and having both are used for filtering of records. Now what does filtering mean? Now for example, when I write select staff from employees, I am selecting all the details from the employees. But when I write select staff from employees where age is greater than 20, so I'm giving a filter. Like I don't want all the details, but I want only the details where age is greater than so and so. So that is filtering. So where and having both are used for filtering, but the basic difference between two is that where is used for filtering at row level and having is used for filtering at group level. Now what this means is row level means individual rows and group level means whenever aggregates are involved, whenever aggregate functions are involved, whenever we are grouping the data, that is, and then we want to filter, then we use filtering. So having clause cannot be used without group by clause in most cases, so just remember it. And we'll see one example where and having is used together in a query, so this will clear your doubts. But before that, let's see these two examples. Okay, now select count sal comma department id from employees group by department id, and I've written a dash over here to to discuss whether we have to write where over here or having. Okay, dash count of sal is greater than 5000. Now what is count? Count is an aggregate function. I hope you all know what are aggregate functions. Count, sum, min, max, all those are aggregate functions. So whenever aggregate function is involved, as I already said over here, whenever grouping is involved, whenever aggregate functions involved, and we are filtering based on aggregate function, then we use having. So here what will come? Having. Okay, now see example number 2. Select staff from employees dash sal is greater than 5000. Here we are filtering based on a single column. Here aggregate function is not involved. Here, as you can see, we have used count. Count is greater than sal. Here we have used aggregate function. We are filtering based on groups. But here we are not filtering based on groups, but these are individual row level filtering. So here we will have where. So I hope these two examples have made it clear for you all that whenever we are filtering, so see, this is the two difference. Here we have filtered based on an aggregate function. Grouping is involved and we are filtering based on this grouping, and hence we are using having. But here in this case, here there is no aggregate function. Here we are filtering based on one single column. So your individual row level filtering is happening. So hence we are using where over here. Okay, now let's see this example. Where and having is used together in a query. So let's see this example. Can we use where and having together in a query? Yes, we can, definitely. So look over here. Select count of id comma country from customer where customer is not where country is not equal to USA. Just see this much query first. Select count of id comma country from customer where country is not equal to USA. Why have we used where over here? Because here we are using country, one single column name we are using over here. Okay, which is why we are using where country is not equal to USA. But as you can see ahead, group by country, then we are grouping it by country. First of all, what we are doing is, we are selecting all these, but we are removing those countries, and we are removing those records where country is USA. So we are removing those, and then we are grouping based on country. So again we are grouping, so India and different countries, we'll group them, and then I am again filtering where count of id is greater than equal to 9. So again all those filtering will happen on based on different countries like India and other countries, and after that wherever count is greater than 9, only those will be printed. So where the count is less than 9, those will not be printed. So I hope that was clear why we used having over here, because here we are doing filtering based on an aggregate function. Got it? So I hope this definitely helped you guys. So again, I'll just repeat it one last time, that here firstly we are filtering based on row level, where country is not equal to USA. Okay, and after that I want to group them. After that I am grouping them by country, by different countries I will group them, and then I'm again filtering based on that count function. So after that, and hence we are using having over here. So generally whenever you're using where and having together, it is not a rule, but generally first where is used, then group by, and then having. So this is the basic order. So as the name suggests, joins basically join two tables based on a common attribute. So they combine rows from two or more tables based on a related column. So as you can see, there are two tables, customers and orders, and join will convert it into one single table based on a single common table between the two. Okay, and there are few types in joins, like inner join, left join, right join, full auto join, self join. So let's see each one of them one by one. So inner join. Okay, so we have two tables over here, customers and orders. Now over here, select orders.or_id, customers.cost name from orders inner join customers on this equal to this. Basically this is the common attribute. So these are the two tables. What is the common attribute between the two tables based on which we can join the two tables? That is id over here and cust id over here. These two are same thing in two different tables. Okay, now so basically in select we'll write all the things which we want in the table. So as it is written, orders.or_id, or id is here, customers.cust name is over here, or id is from the table orders, and cust name is from the table customers. So both of them are in this one single table. So basically we are combining the two tables in this way. From orders is this table, inner join, and instead of inner join you can simply write join also. Join and inner join are same. Okay, from orders inner join customers on orders.cust id is equal to customers.id. So basically it will join both the tables on the common attribute cust id and id. So wherever id and cust id are same, those will be printed over here. So this is how it looks like. This is the first table, this is the second table. Whatever is common between both the table, that will be printed. So as you can see over here, odd id is over here and cust name is here. So or id is here, and based on the common attribute cust id. So 1, 4 and 2. So 1, 4 and 2. Here there are 1, 2, 3. What are the common between the two? 1 and 2 are common between both the tables. Customer IDs 1 and 2 are common between both the tables. So only those will be printed. Okay. So I have marked over here 1 and 2, 1 and 2. So only or ID from here will be printed 601, 603. And corresponding cust name will be printed over here. Okay. So for 601, the cust ID is 1. And for cust ID 1, the customer name is ABC, so ABC comes over here. For 603, the cust ID is 2, the common attribute. Over here, 2, and the common, basically 2 is the common one, and the cust name will be PQR, and that is printed. This is what inner join is all about. Now let's see what is left join. So left join basically means these are two tables. Not only the common rows are going to be printed, but all the other rows from the left table will also be printed. Okay, so let's see from the example. Select orders.or_id, customers.cust name from orders, left join customers on this common attribute. The query is exactly same, just instead of inner join, left join is written. Now this is how it looks like, the left join. So when I write over here, from orders left join customers, so first is orders. The order is here, customers is this circle, and left join basically means the first one, the leftmost one over here. So basically all the rows from the orders table, basically the first table, will be printed over here. So this is our orders table, and or the or IDs will be printed over here. 601, 602, 603, all of them will be printed, and corresponding cus name will also be printed. So ABC and PQR will be printed, but for 602 there is no corresponding cus name, and hence it will be null. So null will be printed over here. So basically left join means all the items from the left table, basically orders table, will be printed over here, even though it does not have a corresponding cus name. Instead of that, null will be printed. Okay. This is right join. Right join is similar to left join, but instead of this, the second table, all the items from the second table will be printed, and also the common ones. And whichever does not have a common attribute from the left table, from the first table, null will be printed over here. So these are the two tables. So the right table is customers, and the attribute from the customers table which needs to be printed is cus name. So all the items from the cus name, all the rows from the cus name will be printed. That is customers, ABC, PQR, MNO. All the three will be printed, and the corresponding OR IDs will be printed over here. So 601, 603 will be printed, and for MNO there is no corresponding OR ID, so it will not be printed. See, for MNO the ID is 3. And is there any ID 3 in this table? No. So hence it will not print anything. It does not have a corresponding value. So null will be printed. This is what right join. Now let's understand full auto join. Full auto join basically means items from both the table will be printed, and if it does not have any common match, null will be printed over here. So all the items from the all the values from the OR ID will be printed, 601, 602, 603, and all the items from the cus name will be also printed. So first of all the items from OR ID will be printed. So 601, 602, 603. So that is printed. Now all the items from the cus name will also be printed. ABC and PQ are already printed, so MNO will be written over here, and hence this is a full outer join. And there's no corresponding value, so null will be written over here. Now what is self join? Okay. Now self join basically means when one table is considered as two tables. Basically where a table is joining to itself. Now where will we need this? So this is a good example which will clearly explain you why cell joins exist. Okay, so there is a table. So it has imp ID, name, manager ID, date of joining. So all the employees have manager's ID. All the employees have manager, and every manager is also an employee, right or wrong? So now if we want to find out which employees are managers, not all employees are going to be managers, right? But all the managers are going to be employees. Wait, I'll understand. It will be clear very soon. Imp ID is 121, 321, 421. Okay. Now as you can see, 121's manager is 321. Okay, 321. And similarly, these have different managers. But if we want to find out which employees are managers, so what are we going to do? Cell join. We are going to join this same table on itself. Okay, and we are going to actually perform inner join, which will print see over here. Select distinct e.name from employee E. This is the table employee. Inner join employee M, another name. The same table is also named E. The same table is also named M. Hence cell join. On what is the common attribute? E.imp ID is equal to M.manager ID. So basically wherever employee ID and manager ID is same, it means that employee is manager. Yes or no? Yes. So basically 321 will be printed, because as you can see the common here there are 121, 321, 421. Here there is 321, 986, 876. What is the common between both the tables? 321. Hence 321 will be our result. This is what cell join is.
So we will write a query to find the maximum salary in each department and minimum salary in each department and average salary in each department. So we're going to write a query for that. So whenever we want to find out maximum or minimum or average salary or anything, we use max, min and average. So that's what I'm going to do. First of all, I'll show you all the table. So this is the table. This is the EMP table, the employee table. It has employee number, first name, last name, job, manager ID, hire date, salary, compensation, and department number. So we have to find the maximum salary in each of these department numbers. So I'm going to write maximum sal. Okay, so sal, so maximum sal from EMP table. Now if I write only this much, it will give me the maximum salary from the entire table, but I want from each department, so I want to segregate the data, so I will use group by. So I have to group by department dpt number. Now what will happen is, see, let's have a look. Okay, now I will get maximum salary of each department, but I also need to print the department number. So okay, I will write department number over here, and this is how it looks. So maximum salary of department number 20 is 3000, department number 30 is 2850, and department number 10, the maximum salary is 5000. And here I will give an alias if you want. Okay, so this is how it looks like. So here the name will change, the maximum salary, department number. This is how the query is written. So what this does is, first it will group the entire table by department number. So all the 20 department number data will be together, then 30 department data will be together, and the 10 department number data will be together. And then in those groups, okay, so it's group by will make groups, and in those groups it will find out the maximum salary. So aggregate function max is used. So max, min, average, these are aggregate functions, and with that we use group by. Okay, and after this, if you want to write any, if you want to add some filters, you can write having condition over here, having so and so something something. So if you want to write filter, but that's not a question. So this is for writing maximum salary. Now if you want to find minimum salary, you can write minimum sal, then average sal, and this is how it's going to work. So maximum salary, minimum salary, average salary, and department number. So you will get the minimum, maximum, and average salary of all the departments like this. Okay, and you can again give alias over here. Minimum salary, average salary. Okay, so yeah, that is it. This is the query to find out the maximum, minimum, and average salary in each department. So we will discuss the query to write nth highest salary, okay, of an employee. So we will be using a ranking function. We will be using the ranking function dense rank. So let's begin with the video. So first of all, what I'm going to do is, first of all, okay, see the table. So my table is, my table name is Duke underscore employees. So this is my employee table. It has employee number, first name, last name, job, manager, hire date, salary, commission, and department number. So since we have to find the nth highest salary, so we have to find the nth highest salary, okay, nth highest salary, okay, from the employees table. So we actually care about the employee number, the first name, and the salary, because we have to find the nth highest salary. So that's all we care about. So what I'm going to do is, okay, first I will write select employee number, first name, okay, then I will also print the salary, and then I will use dense rank. Okay, so I will explain you all what dense rank does in just a bit. So I will use dense rank over what, I will order by salary, okay, okay, as RN. So I will give an alias to this dense rank. So dense rank over order by this as RN. So this is the alias that I'm giving. Okay, so from my table, so I'm gonna write the table name. Okay, now let's see what will be the output of this. So this is the output. Okay, so now what this is doing is dense rank. So what dense rank does is it will give a rank to every record. Okay, and since I've used order by sal, so according to the salary it will give rank. So the uh, since I've not written uh, since I've not written anything over here, it will be considered as ascending order. But if I write descending over here, then the highest salary will be written over here. So the highest will be given the rank 1, then the second highest will be given the rank 2, then the third highest will be given the rank 3, and so on. So if I had not written anything over here, it will be considered as ascending order. So the least salary will be given as rank 1. Okay, so this is the output of this query. Now I will, so what is the requirement over here? I have to find the nth highest salary. So let's say I want to find the second highest salary. Okay, now so which basically means I have to find this salary which will have the rank 2. So I just need to select employee number, first name, and all of that from this output where my rank is 2. Okay, where RN is 2. So what I'll do is select employee number, first name, and salary from this. Okay, now we also have to give an alias, but first I will not give an alias right now, and see, you will get an error because every derived table must have its own alias. So as I said, I have to give an alias to it. So I will give an alias to it as C. So this, okay, this is the derived table. Okay, this is the derived table. So this is the derived table, this is the output, and I'm giving it the name as A. So here I will write A dot empty number, A dot first name, A dot salary. Okay. Now this will basically give me the same output only, but I need the output where the rank. Okay, so the rank, dense rank. Okay, so dense rank has the alias Rn. So where Rn is equal to 2. So this is my output. So employee number 7788 spot having salary 3000 has the second highest salary. Now if I write 3 over here, so this is my third highest salary from the table.
So first let's understand the difference between delete and truncate. So delete comes under DML, that is data manipulation language, and truncate comes under data definition language. Delete removes some or all the rows, and truncate removes all the rows from the table. So query would be something like delete star from employee where ID is equal to 100. So this query can be used to remove specific rows from a table, and when you want to remove all the rows from a table, we use query something like delete star from employee, and the query in truncate would be truncate table employee. So whenever you want to remove a specific row from a table, we use delete with where clause, but in truncate we can no where clause is used. Okay, so this is one difference between delete and truncate. So the other major difference between delete and truncate is that it does not free the space containing the table. So basically what this means is when you remove the rows from a table using delete, the space in which it was occupying initially is not deallocated. Whereas in truncate, it frees up the space containing the table. Okay, so the transaction log in when we use delete will still have the deleted rows, so the space is never deallocated. Okay, so it is never freed. Okay, in delete, and in truncate the space is freed. So now let's understand what drop does. Drop removes table from the database. So once you drop a table, it cannot be recovered back. And when you drop a table, all the rows are deleted. The table structure is removed, everything is removed from the database, so it cannot be rolled back. And the query is something like drop table employee.